When you are adding and subtracting rational expressions, it's just like when you add or subtract fractions, you need to have a common denominator. So to find the common denominator, you need to multiply both expressions to make the denominator the same. So for this one, 2x over 7 and 5 over 3x. First, we need to say what our non-permissible values are, so x cannot equal 0. Now we're going to multiply. Now to get this side the same as this side, we can multiply by 3x. So whatever you do to the bottom, you have to do to the top. And to make this side the same as the left side, we multiply the top and the bottom by 7. So if we multiply this out, we should get 6x squared over 21x plus 35 over 21x. Make sure you get to this step and see that your denominators are the same. From here, we just add the numerators. Do not add the denominators, just leave them. So on the top, you should have 6x squared plus 35 all over 21x. And check to see if it can be simplified. This one can't. So when x does not equal 0. And that's all you have to do. So first, non-permissible values. Second, multiply to get your denominators the same. Third, add your numerators. Fourth, check to see if you can simplify. For this example, we need to figure out first what our non-permissible values are. So we know that a can't equal 0 and b can't equal 0. Now we need to figure out what we need to multiply to get everything the same. So we've got a 5ab and a 4b squared. So to get our 5's and our 4's the same, we need to multiply by the other number. So this side will multiply by 5, this side will multiply by 4. To get our a's the same, we need to multiply our 4b squared by a. That will make them have the same amount of a's. To have the same amount of b's, we need to multiply our 5ab by 1b to make it squared. So this is what we will be multiplying by to make the denominators the same. When we multiply it out, we should get 16b over 20ab squared minus 15a over 20ab squared. The denominators are the same, so we know we multiplied by the right values. Now we are going to add across the numerators. So we have 16b plus minus 15a over 20ab squared. Check to see if it can be simplified. This one can't. So when a does not equal 0, b does not equal 0. And that's your final answer. So remember not to add the denominators, but keep the denominator the same. For the next example, first find your non-permissible values. X cannot equal 0. From here, we need to figure out what we need to multiply by. So to get our coefficients the same, we're going to multiply this side by 8 and this side by 6. To make our x variables the same, we need to multiply the left side by x to make it x squared. So we're multiplying the right by 8 and the left by 6x. Now when we do this, we have to make sure to distribute the 6x into both of the terms in the binomial on the top. So on the top, we should have 6x squared plus 30x over 48x squared plus 8 times x is 8x minus 56 over 48x squared. Now we're going to combine our terms. So we have 6x squared plus 38x minus 56 over 48x squared. So we add it across the top. Now we're going to check to see if we can simplify. Everything can be divisible by 2, so we're going to divide the top and the bottom by 2. So we're left with 3x squared plus 19x minus 28 over 24x squared when x does not equal 0. For the next example, we know that c can't equal 0 and also d can't equal 0. Now we need to multiply the left side by a number to get our coefficients the same, so we'll multiply by 5. We need c to be squared, so we're going to multiply by c. So on the left side, we should be multiplying by 5c. On the right side, we'll be multiplying by 3. Now we're going to distribute in, so we should have 15c squared minus 10c all over 15c squared d, subtract 3c plus 24 all over 15c squared d. Now, because this is a negative, we're subtracting. We have to remember to distribute the negative into the 3c and to the negative 24. So this should be 15c squared minus 10c minus 3c minus 24 over 15c squared d. Now we can simplify, so we should get 15c squared minus 13c minus 24 all over 15c squared d. Look for a common factor. There is not one, so when c does not equal 0, d does not equal 0. For the next example, we need to make all of our denominators the same. So we need to figure out a common number to multiply them all by. So first, a does not equal 0. So we have a 2, a 4, and a 3. So we want to find the least common multiple, so the multiple that's the lowest between the 3. So if you multiply them all together, so 2 times 4 times 3, you should get 12. So we're going to want it to be 12. Nothing is lower than that. So when we multiply, we also want to have 2a's. So for this one, we're going to multiply by 4 and by 3a squared to get our denominator the same. For this one, and I was just kidding when I said this was 12, this is 24. For this one, we need to multiply by 3 and by a 2, and by this one, a 2 and a 4a. So as you can see, you're multiplying by all the other denominators and then making sure your a value is to the right degree. So multiply the top by 4 by 3a squared, this one by 3 and 2, and this one by 2 and 4a. So this should turn into 5 times 12a squared over 24a squared minus 3 times 6 over 24a squared plus 2 times 8a over 24a squared. So this will make it all the same denominator. So on the top we have 60a squared minus 18 plus 16a, all going to be over 24a squared. And now we can take out a 2, so we should be left with 30a squared plus 8a. I switched these spots to put the a first, minus 9 all over 12a squared when a does not equal 0. For this example, we're going to multiply each of the denominators by the other denominator's coefficients. So we'll multiply this one by 3 and by 8, and we need a z squared, so multiply by z squared. So do that to the top and the bottom. For the next one, we're going to multiply by a 6 and an 8, and we need one more z. So 6, 8, and a z. And the last one, we're going to multiply by a 3 and a 6, and our z's are at the right degree. So this is going to turn into 18 times 2z plus 1 over 144z squared plus 48 4z minus 4 all over 144z squared minus 24z squared times 8 minus z all over 144z squared. So now we're going to distribute inner brackets, and we should get 18 times 2 is 36z plus 18 over 144z squared plus 192 z's minus squared, sorry, that should have been squared, minus 192z over 144z squared minus 192z squared minus 24z to the power of 3 all over 144z squared. Now we are going to rewrite it with all as one rational expression. So we have, and we're going to put our terms together. So we have 192z squared minus 192z squared. So that's those. Plus 36z minus 192z plus 18 minus 24z to the power of 3 all over 144z squared. If you want to skip this step, you can. The final answer, this cancels this. You're left with negative 24z to the power of 3 plus 36 minus 192 is minus 156z plus 18 all over 144z squared. We can take out a common factor of 6 from these. I'm going to write the answer over here. So our final answer should be negative 4z cubed minus 26z plus 3 all over 24z squared when z cannot equal 0. And we didn't do that at the beginning, but z cannot equal 0 from this.